In this video, we are going to do some factoring examples. This way you get more practice and recognition with the different types of polynomials and factoring that you can do. So in this first one, we have 18n to the fifth minus 45n cubed plus 54n to the fourth. This is a fifth degree polynomial, and you don't know how to solve or factor polynomials that are that big, and so it's a good bet that this is just a polynomial where you're going to take out the common factor. So looking across all three coefficients and variables here, I see that the common factor I can take out is 9n cubed. That's what each term has. And so if I take a 9n cubed out of the 18n to the fifth, I get 2n squared left. If you take 9n cubed out of the second term, you get negative 5. Then if you take it out of the last one, you're left with 6n. So then your final answer would be 9n cubed times 2n squared minus 5 plus 6n. And you can rearrange that if you want, or just leave it like that. That's fine. Alright, so if I look at the second one, I have negative 32a plus 48a squared plus 24a to the fourth. Again, this is a higher degree polynomial that I don't know how to solve, and so it's a good bet that I need to take out a common factor. So looking at all three of these terms, I see that I can take out an 8a from each term. That's going to leave me with negative 4 plus 6a plus 3a squared. Alright, next. Number 3, we have 4m squared minus 1. Thing that you should pick up on this is that 4 and 1 are perfect squares. And then you have a subtraction sign right here. So this is a difference of perfect squares. So to approach those, I want to take the square root of each of these terms, basically. So 4 is going to be 2 times 2. So I have 2m times 2m. And then 1, well, that's just 1 times 1. So I know those are going to be my constant terms. And then I have a minus, because the difference of squares, that means I have a plus and a minus in each of my factors. If we look at number 4, this is also a difference of squares, because x squared is just x times x. And then the 25 here is just 5 times 5. So I'm going to have a plus 5 and a minus 5. The reason I have a plus and a minus in each of these factors is because if I go back through and distribute here, x squared minus 5x plus 5x minus 25, that gets rid of my middle term, and I'm just left with the x squared minus 25. So having a plus and a minus gets rid of that b value. And so when you have two terms here, and they're both perfect squares, then you know this is how you can factor it, with always having a plus and a minus in your factors. Alright, next two, I have x squared plus 4x plus 4. So something I noticed first about these is that that's a perfect square, and this is a perfect square. So that means I'm dealing with perfect squares, and it's an addition. Everything's addition here. Notice, like on 3 and 4, it was a subtraction one. So in this problem, I've got a plus 4 here. I'm adding that perfect square. So I have x plus 2 times x plus 2. It's going to repeat itself because the x squared is a perfect square and the plus 4 is also a perfect square. So you can write x plus 2 times x plus 2, or just condense into x plus 2 squared. For number 6, I have 9n squared plus minus 6n plus 1. Again, this right here, 9n squared, is a perfect square of 3n and 3n. And this plus 1 is also a perfect square. So I know that I am going to be dealing with factors that are the exact same. So I have 3n minus 1 and 3n minus 1, which gives me 3n minus 1 squared. The reason I know this is a subtraction sign here versus over number 5 I had an addition sign is that b value. This is a minus here, so I need to subtract some terms. You can double check. If you distribute 3n times 3n is 9n squared, minus 3n gives me that minus 6n. And on 5, x times x is x squared. 2x plus 2x gives me that positive 4x. And so paying attention to that b value, whether it's positive or negative, will help you figure out in your factor whether you have a plus or a minus. That only works in this case because they are perfect squares. You'll see, for example, here in number 7 that the b value is negative, but that my factors aren't going to be negative exclusively, like it was in 5 and 6 here. In 5, I had a positive b value, so in my factor, it was a positive in the middle. And on 6, my b value was negative, and I had a negative in the factor. That's not always going to be the case. So for number 7 here, first thing I want to do is write down the factors of negative 15 here. This negative is very important because that means I'm multiplying a negative and a positive. I can't multiply two positives to get that negative value. So I can write down the factors of negative 15, which are going to be negative 3 and 5, or I could have negative 5 and 3. You could have negative 15 and 1, or negative 1 and 15. Now, that happens to be all of them for negative 15, but let's say by luck you just wrote down the first one right away, or as you practice these and you get better and better, and you wrote down what you needed right away, you can stop. You don't need to list all the possible factors available. So to get this negative 2 b value, I need to have a negative 5 and a positive 3 factor. So that means this number 7 factors into k minus 5 and k plus 3. And so that's what I mean by, even though in 5 and 6 the b value matched what values I had in my factors, whether they be only positive or only negative, that's not the case here on number 7. I actually had one of each. Alright, so number 8, I can break positive 30 into a positive 5 and a positive 6, or a negative 5 and a negative 6. Because a positive times a positive is positive, but a negative times a negative is also positive. I could also turn this into 15 and 2 if I wanted, or negative 15 and negative 2. And there's more that I can do, but I see my answer already, which is positive 5 and positive 6. The reason I know that one is positive is because the b value is positive. So again, paying attention to the b value is very, very important in all of these types of problems. Alright, so I know 5 and 6 add to 11 and multiply to 30, so my factor is x plus 5 and x plus 6. Alright, if I look at number 9 here, I have 5r squared minus 320. First thing you always want to do is take out anything that the polynomial has in common. So these terms, I can take out a 5 from both of them, which is going to leave me with r squared minus 64. Well, and then I notice r squared, perfect square, minus 64 is another perfect square, so I have a difference of squares here. I'm going to use what I know about difference of squares to continue simplifying this problem. So I bring down the 5, r squared minus 64, again, difference of squares, I know that's going to be r minus 8 and r plus 8. Alright, looking at number 10, again, pulling out what everything has in common. Especially when numbers are really big, that's the first thing you should look for. So what can I pull out? Well, in this case, I can pull out a 6 from everything. So that's going to leave me with v squared plus 9v minus 10. I'm going to bring down this 6 and then just factor that inside, v squared plus 9v minus 10. So this negative 10, I need to write down my factors. That's going to give me negative 10 and positive 1. negative 1 and positive 10. You can also have negative 5 and positive 2. But I know that my b value adds up to a positive 9. And so when I look at these factors over here, the ones that add to a positive 9 are the negative 1 and positive 10. So that means this inside factors to v minus 1 times v plus 10. And you can always double check your work by going back through and multiplying.